Now, last time we discussed about making an electromagnet. So how you can produce an artificial magnet by using electricity. The new topic, this one is found on your science book, is the unit 13.5. And as I said, it's related with the strength of an electromagnet. So today we will see which are the properties or the factors that affect an electromagnet. Now, to understand factors that affect electromagnets, first let's recall how does an electromagnet work. We said that the condition is what? Electricity. Now, electromagnets usually consist in what? In a wire turned into a coil. When current passes through it, what happens to the wire? It experiences a magnetic field which is concentrated in a hole denoting as the center of the coil. Now, the magnetic field disappears when the current is turned off, so you can't control it. The wire turns are often wound around the magnetic core, such as iron. The magnetic core concentrates the magnetic field and makes the magnet or the electromagnet more powerful. And as you see, you have a simple diagram that represents a power supply, a battery that produces chemical energy, and then when it comes out, it comes as electricity. Around the wire, it experiences a magnetic power, and as you see, if you brought near to it a compass, what happens? It deflects because it shows that the wire experiences a magnetic power, okay? Now, let's recall some differences between permanent magnets and electromagnets at the end.
Okay, a permanent magnet doesn't require electricity to work, while an electromagnet, of course, requires electricity to have magnetic properties.
Well done. So the first condition is electricity. Permanent magnets do not require electricity to act like a magnet. Of course, for electromagnets, it's necessary to use this form of energy, electrical one, to experience magnetic power.
Again, me or someone else?
Yeah, go on.
Okay. A permanent magnet cannot be switched off because it is permanent and has those magnetic properties for a very long time. While an electromagnet, seeing as it requires electricity, we can turn off the source of electricity and it will no longer hold the magnetic properties.
Good. Now, what about except being permanent or temporary magnets? What about the invented year? So what about electromagnets? 18 and 20 is the year that was invented, the electromagnet. But what about the permanent one, like the natural one? Or why not the artificial one? It was discovered 2,000 years ago in a place called Magnesia. This is the reason why it gets this term as name, magnet. Okay, so there are found some rocks that experience some magnetic powers, and as I said, in a place known as Magnesia, they get this name, magnets, and then we can control their strength to see their uses in different appliances or devices. Okay. Now, how to make an electromagnet stronger? So, okay, now we know how to make an electromagnet, but how we can control the strength or how we can increase or decrease its strength. Now, how to make an electromagnet stronger? Can you check what you have on your screen? You have some coils of wire. The first diagram represents just the coils of wire, but the difference between them is the number of turns. So the first coil do not have as much turns as the second one. At the second diagram, what you have? You have the same number of turns at both of them, but what about the power supply, the batteries? At the first one, you have just one cell. At the second one, you have two cells. So which one provides a greater voltage or a greater power supply between them?
The second one.
The second
one that it has to batteries. Okay, so can you guess, according to the diagrams, what will be the factor that will affect the strength of an electromagnet?
Number of turns and the amount of voltage, maybe?
Good, number of turns. The first one should be the number of turns. And then the amount of voltage, or differently, we can define it as electric current. Okay, so let's see all the factors that affect the strength of an electromagnet. You can make an electromagnet stronger by doing these things. The first one, adding the number or just adding inside the coil a soft iron bar. This is the first condition. Can you check the diagram? So it's the same one. We have always the same diagram to represent electromagnets, a power supply, a switch to let the electricity pass through the wire, and then a coil of wire. Right here, the difference is that we have put inside the coil what? A soft iron bar. Why? To increase the strength of the electromagnet. This is the first factor that affects electromagnets. But why we put a soft iron bar into a coil of wire? What do you think? Why we should use this kind of material to increase the strength of an electromagnet? Davis?
Yes, teacher.
Why we use iron to increase the strength of an electromagnet? Do you have any idea? So the first
Because we said the iron is a magnetic material.
good. So if you put inside the coil, it will get easily
it will-
magnetized. And
Yes.
then it is easy to demagnetize it as a material. So this is the reason why we use soft iron. Okay, good. And you increase the strength of an electromagnet just by using it. Okay, but why we can't use steel? Ines?
Yes. Teacher, can you repeat the question?
What do you think? Why we can't use steel in this case? So I said that the first factor that affects the strength of an electromagnet is by putting inside the coil of wire soft iron. So an iron core to increase the strength, to increase the power of the electromagnet. Why you can't use, for example, steel as a material? Do you have any idea? How we can?
Because steel is known as a hard magnetic material.
Very good. So steel is known as a hard magnetic material. But which is the meaning of being a hard magnetic material? So if I will turn off, in this case, at the magnet or electromagnet, the electricity, what will happen to the piece of steel that you have put inside the coil? It will still continue to experience the magnetic power or not. So this is the reason why we can't use, in this case, steel, because as I said, it is used as hard magnetic material. Okay, so as I said, the first factor is adding iron core. What about the second one? We said that the number of coils, adding more turns of coil is another factor that affects the strength of an electromagnet. Can you check the diagram that you have on your screen? You have a weaker electromagnet and a strong electromagnet. Which is the difference? You have the same power supply, so 6 volts cell in this case, but what about the number of turns? It changed. The first one has less number of turns, the second one has more number of turns. So it means that the number of turns is another factor that affects the strength of an electromagnet. By adding it, you increase the power of the electromagnet. Okay? What about the third factor? Of course, that should be what? Current, electricity, or voltage, power supply. You can find it in different terms. Now, another way how you can increase the strength is by increasing the current flowing through the coil. So the third factor that affects the strength of an electromagnet is electricity, by increasing electric current that passes through the coil. If you increase the current, you increase the power of an electromagnet, okay? But what is electric current? Now, we discussed that we should use electricity to make an electromagnet act or experience a magnetic power. Now, let's recall what is electricity. What do you remember about electricity? Which are the particles or charges that are related to electricity? So general information, what do you remember about electricity? Migi. Mustafa.
Yes.
So what do you remember about electricity, teacher? Just in general.
So electricity is, let's just say, the name that we use for when electric current moves.
Okay. But which one moves and when? There?
Electrons?
What do you remember about electric current, teacher, as physical quantity? There? Are electrons related with electric current there?
I was going to say the flow of electrons.
Good, the flow of electrons, the flow of electrons. The flow of electrons through a wire there, good.
Yeah.
Okay. Now, so what is electric current? Of course, it is related with the moving of charges, but what charges? What are these particles that are free to move through a metal, through a conductor, and what we call conductors? Geldi. Geldi. What are conductors, teacher? Geldi?
Teacher, can you hear me?
Mm-hmm. What are conductors?
Conductors are objects that can conduct electricity.
Very good. So conductors are materials that conduct electricity. So there says that electricity is related to movement with the movement of charges, of electrons. So
Free electrons.
the flow of electrons or electric charges through a conductor is just called electric current. Okay, so this is the definition about this new physical quantity that we get today. Electrical current is just the measure of the flow of electric charges. Don't forget that electric charges are always electrons because just electrons are free to move through a conductor. Okay?
Okay.
Good. Now, Shafrin.
So,
Now, electrons are negatively or positively charged?
electrons?
Mm-hmm. What do you think? So they are the only type of particles that are free to move through a wire, but the wires are good conductors, so are made up by metals usually. So what do you think?
I think they can be positive and negative, or only negatively charged.
Okay, they have just one charge and they are negatively charged.
Negative.
Marson. 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 What about the structure of an atom? So as electrons are part of an atom, and we said that they are negatively charged, they are free to move through a wire. What about the structure of an atom, Angie?
So an atom is made of electrons, protons, and nucleus, and neutrons.
Well done. Which one is in the center or at the nucleus? And
it's protons and neutrons.
very good. Protons are positively or negatively charged?
Positively.
Of course, they're positively charged. And then our electrons that surrounds the nucleus. Okay, good, well done. So as I said, again, what is electric current? Of course, that is just a measure of flow of charges. Don't forget that these charges are always electrons and they are negatively charged. They flow through a wire known as conductor. Conductors are materials that allows electricity pass through them. They have a low electrical resistance because, as we said, they allow electricity. The reason why they allow electricity pass through them is because they contain a larger number of free electrons, okay? And then metals are usually good conductors. Now, what about the SI unit of electric current? Is ampere, or just shortly amps. A is the symbol that we use to represent this physical quantity. Today we will get the formula of electric current too, but we will not use it, just for general information as we use electric current to define or to make an electromagnet, okay? And the formula of electric current is this one, the magical triangle, as we have learned. Now, current is equal to charge over time, charge over time. We said that current is the flow of charges. Charges are denoted by Q, and then over the time that it takes to flow through the wire. And then you have a symbol diagram that represents how this form of energy passes through a wire. Now you have a battery. Don't forget that batteries are devices or components that produce chemical energy. When this energy comes out from the battery, it changes into electrical one by passing through the wire. And then as you see, it passes through the whole wire. It shows the electrons that they are negatively charged. And don't forget that we use this form of energy to produce a bigger or stronger electromagnet, a powerful one. But which is the device that we use to measure electric current? We make use of an ammeter to measure electric current. This is the device, this is the component or the instrument that we use to measure electric current. The rule to connect an ammeter is always in series with the circuit. Previously, you have learned something about circuits, components, diagrams, and so on. And current must flow into the positive terminal and leaves the negative terminal of the cell, as you have learned previously. Okay, so that's all about electric current. Now, at this diagram, you have a shortest way to understand how we can use electromagnets in daily life. Last time we discussed about using them in generators, motors, hard disks, I don't know, different uses in daily life. This one is electric bell. So how we can use this this form of force of magnetic one to produce or to use in our daily life. Can you check it how it works? So you have a power supply, you have a battery. You have a battery, as you see, that produces electricity. When you close the switch, electricity continues to pass through the wire. It passes through the wire. So what happens to electricity? Now, by making some turns around the U-shaped magnet, as you see, it experiences a magnetic power. Right here you have a bar magnet that is attracted by the U-shaped one. But right here you have, again, a ring magnet and what? A nail that is made by iron, that it attracts the bar magnet to. And as you see, up and down, it produces the sound of the bell. So this is the way how it works shortly, an electromagnet. Now, some summarized information. What happens with the electricity that it passes through a coil of wire? It behaves like a magnet and it has a magnetic field that is known as an electromagnet. Now, how we can increase, how we can make a powerful electromagnet? In three ways. Run the coil of wire around the iron core. So this is the key word. Iron core is the first condition. Increase the number of coils or the number of turns, increases the strength of the electromagnet. And then increase the size of current. That is the third condition or factor that affects the strength of an electromagnet. Now we have discussed that electromagnets can be easily turned off and on as we use electricity to produce them. And then we have learned some uses about electromagnets in our daily life in electrical devices or appliances. So that's all about next time. As homework, you will have question 1 at page 171. And except it, you will have this exercise. So you have a large electromagnet used to lift scrap. You will describe what metals would the electromagnet attract or what advantages does an electromagnet have over the permanent magnet. So must say the difference between them, permanent and electromagnets. Questions?
No.